Welcome to another physics class again. In our last lesson, we stopped on coefficients of friction in an horizontal plane. And I promise that in the next lesson, we are going to look at coefficients of friction in an inclined plane. If you study what I've done on the board, look at this weight now that is placed on this inclined plane. Make an angle theta to the horizontal. Let's say this body now wants to be in equilibrium. Then what are the vectors of these coefficients of friction on the body? We need to derive some formula to solve problem on this topic. Now, let's look at this body now. Place on this inclined plane. Make an angle theta. As I said, during coefficients of friction in an inclined plane, there must be normal reaction force, which is denoted by R. And that one, as we explained in that lesson, it must be perpendicular to the surface. Then the weight of this body acting downward. And apart from that, there must be horizontal force and the frictional force that will make the body balance horizontally. Now, as we are looking at it now, let's look at it and derive some equation out from what we have drawn on the board. Now, for this body now to be in equilibrium for the body to be in equilibrium. This F is horizontal force. The frictional force also is horizontal force. While this normal reaction is upward force, and this one also is upward force. Let's now resolve it into vertical and horizontal component. So if you want to resolve this one, you take it like this. As I said, normal reaction must be perpendicular to the surface. This is our R. Then the weight of the body will act downward. This is the weight of the body. Then the horizontal force, like this, going like this, and the frictional force in the opposite direction, moving like this. But once both are horizontal, let's make use of ordinary F, and this is angle theta. Now, to resolve this one now into horizontal component now, resolve into horizontal component. So we are going to have, for the horizontal component, first, we close this one, which is normal reaction. We call this one the horizontal force or parallel force. Then we take care of the weight of the body and the angle. And from this one will be opposite and hypotenuse. That will be sine theta. Sine theta will be equal to F over W. Don't forget the W is the weight of the body. Therefore, our F will be equal to W sine theta. And this one is called parallel horizontal force. Parallel horizontal force. Note it is a formula on its own. Then again, if you resolve it vertically, or on the vertical component. So you close the horizontal force, make use of the normal reaction, the angle, and the weight of the body. So we are going to have This side is adjacent to this angle, and this is hypotenuse. That will be cos theta. Cos theta will be equal to, which is adjacent over hypotenuse, R over W. And the R now, which is normal reaction for force that is perpendicular to the surface, will be equal to W cos theta. So this is the perpendicular force, perpendicular force, or force that is normal to the surface. Normal to the surface. Force that is normal. Normal force to the surface. Now, from what we have seen on the board now, we have seen two formulas. The first one, the parallel horizontal force, which is F is equal to W sine theta. And the second one, normal reaction force, which is equal to W cos theta. Now, don't forget, from mu is equal to Fr over R. That is the limiting frictional force over R. Why this one is coefficient of friction. And from what we've drawn on the board now, I said, don't forget, for this body to be in equilibrium, F must be equal to Fr. If that is the case, we can now say, according to this thing, this one also can be F over R. And from what we have seen on the board now, our F is what? W sine theta. And our R is what? W cos theta. So we can now say, therefore, the coefficient of friction will now give us W sine theta over W cos theta. And from what we have seen on the board, don't forget W is the weight of the object placed in an inclined plane. So we can now say W will cancel W. Then from trigonometric ratio, sine theta over cos theta will give us tan theta. So you can now say that mu, which is coefficient of friction, will be equal to tan theta, since sine theta over cos theta is equal to tan theta. That is from trig ratio. So we can now say that the coefficient of friction in an inclined plane is equal to tan theta. Now, we're done with in a case when the body is in equilibrium. Let's now look at it. If the body is to move up the plane, then what will be the resultant horizontal force? The body moving up the plane now. That is, want to pull up this body up the plane now. Then what will be the resultant horizontal force? Resultant horizontal force. Then that one, let's now consider it. P, this is the applied force that to pull it up. As we are pulling it up, the frictional force will oppose it. Mind you, we said this is the parallel force that parallel to the surface. That one is constant. So consider the symbol on the board where P is equal to applied force. So if we now consider the force, the three forces on the board, we are going to have P. Since these two are in the same direction, minus F, that is the horizontal parallel force, plus Fr, then equal to 0. That is when there is no acceleration. When there is no acceleration, when it's just to pull it up to overcome the static friction only. If there is no acceleration, then we have P minus F plus Fr. Why is it plus? Because they face the same direction. And from this one now we can now have P now will now be equal to F plus Fr. And if you substitute the value of this, the magnitude of this one, which we derived the other time, and the magnitude of this one, that is the frictional force. So this one, you can now say, but F is equal to sine theta, and Fr is equal to the coefficient of friction multiplied by normal reaction. So when it is being pulled up or moving up, then the applied force will now be equal to W sine theta plus mu r. That is when there is no acceleration. But if there is acceleration now, then if acceleration takes place, then we are going to have this our P minus F plus Fr in bracket will be equal to ma. That is the force that we accelerate, since F is equal to ma. That is the accelerating force. So since F is equal to ma, so we are going to have P is equal to F plus Fr in bracket equal to ma. So let's say we have to calculate the acceleration now. So we can apply this formula. If the question say there is no acceleration, but the body is just overcome static friction, then we can apply either like this or this one. That is another equation. Now, let's look at this inclined plane and the body on it in number 3 dimension. That is, when the body moving down the plane, as the angle theta increases, therefore the body will slide down the plane. If that is, he has angle theta increased, the body will slide down the plane. And if that is the case, the body slide down the plane, it means this force P, therefore P as force will be equal to 0. You don't need to apply any force. So P will be equal to 0. If P is equal to 0, then we are going to have that F, since the body is trying to slide down, then the limiting frictional force we have to the opposite direction. That will be F minus Fr will be equal to 0. That is when there is no acceleration. So from there now we can now say that F will be equal to Fr, and from there we can now say that F is equal to mu r. Again, if there is acceleration, the same formula, this formula, F minus Fr will be equal to ma. Then acceleration takes place. Then we are going to have F will be equal to Fr plus ma, and we are going to have F will be equal to mu r plus ma. That is when the body is sliding down the plane, If there is acceleration, we are going to have this one. If there is no acceleration, we are going to have it like this or like this. So these are the possible equations we can have in this body that is placed on an inclined plane. As I said in the first instance, when the body is in equilibrium, then we have the horizontal parallel force and the normal reaction force. When the body is moving up, we have the possible equation which we've done already, and when the body is moving down, then we have this equation. Take this one as example 1. A body inclined at angle 30 degrees to the horizontal level. Calculate the coefficients of static friction as it slides down the plane. Now, from this question now, the only parameter given is our angle of inclination. Angle of inclination is equal to 30 degrees. We now have to calculate mu, that is the coefficient of friction. And from what we've done so far, so the coefficient of friction, once it is in an inclined plane, mu will be equal to tan theta. And our theta is what? That is 30 degrees. So our mu now is equal to tan 30 degrees. And tan 30 degrees is equal to 0.577. That's the value of coefficient of static friction at the body inclined at angle 30 degrees. That's for example 1. Let's take this one as example 2. A 10 kg mass is placed on a rough inclined plane at 30 degrees to the horizontal. Calculate the 1. Force parallel to the plane. 2. Force perpendicular to the plane. 3. Coefficients of static friction. G is equal to 10 meters per second square. Now, solution to this one. Now, what are the possible parameters given to us? Theta is given, that is angle is given as 30 degrees to the horizontal. Then mass of the body, L, is given 10 kg. Then G is given 10 meters per second square. Now we have to calculate force parallel to the plane. Let's put it into draw. Let's say this is the body. The mass is 10 kg. Then force parallel to the plane. Then we have to calculate force perpendicular to the plane, which is normal R. Now, from what we have done the other time, without wasting our time, 1. Force parallel to the plane. That one will now give force parallel to the plane. Then that one will now give F is equal to W sine theta. Don't forget, we've derived this formula the other time, and since weight of this body is not given, but mass is given, and we were given G as 10 meters per second, you can now say that will be mg sine theta. W is equal to mg. So that will be the mass of the body is 10. 10 multiplied by 10 sine 30. And that will be 100 multiplied by 0.5. So this one will now give 0.5 multiplied by 100 will now give us 50 Newton. That is the force parallel to the plate. Number 2 question, which is force perpendicular to the plane. Force perpendicular to the plane. Don't forget, force perpendicular to the plane is also known as normal reaction force. And the other time we said the normal reaction force is equal to R is equal to W cos theta. And from here now, our R will be equal to mg cos theta. Our m is 10, g is 10, then cos 30. And don't forget, cos 30 will give us, this is 100 multiplied by 0.866. Now, force perpendicular to the plane will be equal to 86.6 Newton. The last question asks us to calculate the coefficients of static friction. And don't forget, mu, which is coefficients of static friction, as we said the other time, is equal to Fr over R, which is equal to F over R. And our F here, which is force parallel to the plane, is 50. That is 50 divided by 86.6. Now, mu now equal to 0.577. That's the solution to the example 2. Now, this is convenient point to stop for today's lesson. In our next video, we are going to continue to give more examples on coefficients of friction in an inclined plane. And if you are not with us before, or you are just joining us today, please try to like, share, and subscribe so that when I upload a new video like this, you'll be able to get the notification in time. Thank you.